Welcome back to Daily AI News at Let's Data Science. It's 2026-05-25. Today we're diving into some pivotal developments, from the future of machine intelligence to major product launches. Let's get to it. We begin with a significant policy and procurement development in Washington involving Anthropic and the National Security Agency. According to reporting by AI Weekly and coverage indexed by Finance Feeds, White House Chief of Staff Susie Wiles overruled a Pentagon supply chain risk designation in order to preserve Anthropic's classified contract with the NSA. The decision reportedly keeps Anthropic's Mythos and Claude systems running on hardware already deployed inside classified networks. Why does that matter? Because hardware compatibility is often the hidden constraint in government AI deployments. The reporting notes that competing frontier models reportedly require newer NVIDIA Grace Blackwell chips, which are not yet widely available inside older classified environments. In contrast, Anthropic's stack is already engineered to run on legacy infrastructure currently operating within NSA networks. The revised NSA contract reportedly removes a previously contested any lawful use clause and adds an explicit restriction on processing Americans' data. That contractual change is notable for practitioners tracking AI governance in national security contexts. It suggests that model access and hardware availability are now intertwined not only with performance metrics, but with policy safeguards embedded directly into procurement language. Also critical, the White House has authorized a $9 billion chip procurement request, pending congressional approval. If that funding clears and accelerates deployment of newer accelerators like NVIDIA's Grace Blackwell family into classified environments, the competitive balance among frontier model providers could shift significantly over the next 12 to 24 months. This story underscores a structural reality. In high security environments, compatibility with existing compute stacks can outweigh theoretical model superiority. For AI engineers targeting regulated or sovereign deployments, hardware alignment may be as strategic as parameter count. Next, we turn to infrastructure developments in China's AI ecosystem, where DeepSeek V4 has completed adaptation to Huawei's Ascend chips. Reuters and multiple industry outlets report that DeepSeek V4 was adapted in April 2026 to run on Huawei's Ascend AI compute family, including the Ascend 950PR and Ascend 950DT. TrendForce, SCMP, and eWorld describe this as day zero adaptation, meaning compatibility was achieved immediately at launch. DeepSeek V4 supports a 1,000,000 token context window and comes in two variants, DeepSeek V4 Pro and DeepSeek V4 Flash. TrendForce reports that the Pro version has 1.6 trillion parameters with 49 billion activated per inference, while the Flash variant has 284 billion parameters with 13 billion activated per inference. The architecture reportedly uses hybrid and sparse attention mechanisms to make million token processing computationally viable. Beyond model specs, the strategic story is hardware-software synchronization. Chinese chip vendors, including Huawei Ascend, Cambricon, Hygon, and more threads reportedly completed near-simultaneous adaptation. Historically, such tight coupling was more commonly associated with NVIDIA's GPU ecosystem. Rapid adaptation shortens the lag between model release and production deployment, particularly for domestic on-premises inference stacks. TrendForce and SCMP report that broader Ascend 950 supernode deployments in the second half of 2026 could increase throughput and lower pricing for the Pro variant. However, none of the cited sources provide audited, third-party production benchmarks at scale. For practitioners evaluating deployment options in China, the key question is whether reported compatibility translates into sustained utilization rates and cost-performance advantages in real-world environments. Still, this marks a milestone in reducing reliance on NVIDIA's ecosystem for frontier-scale inference. Now let's move into research, starting with Praxis, case-distilled and code-verified AI agents for biological research, published as ArXiv paper 26055.23169. Praxis is a framework for verifiable biological research agents that encodes research experience into structured long-term memory. Specifically, it uses what the authors call case distillation to store both successful and negative cases, domain rules, failure boundaries, and executable procedures. The instantiated agent suite targets biomedical computing tasks. Evaluations include object validation tests, case retrieval benchmarks, memory ablation studies, public benchmark comparisons, and cross-agent workflows. According to the paper, incorporating case-based learning improved method selection, reduced errors, and enhanced workflow organization. What's technically important here is the explicit pairing of case retrieval with memory ablation experiments. By removing stored cases and measuring performance degradation, the authors attempt to quantify the value of persistent, structured memory. That's a step beyond prompt-only orchestration. For practitioners building agentic systems in regulated scientific domains, Praxis points toward a design pattern: persistent, auditable memory stores that encode both positive and negative precedent. If code and datasets are released for independent reproduction, this framework could influence how AI agents are integrated into biomedical pipelines, where traceability and reproducibility are paramount. Our final top story bridges mechanistic interpretability and neuroscience. In the Arxiv preprint 2605.23035, titled Sparse Autoencoders Map Brain LLM Alignment onto Cortical Semantic Topography, Dongxin Guo and colleagues apply sparse autoencoders to GPT-2 XL and Llama 3.18b. They decompose intermediate layers into 16,000 to 32,000 interpretable features per layer. Using fMRI-based neural encoding analyses, the authors report that semantic features alone recover 94% of peak neural encoding performance, with a reported correlation of R equals 0.285. They also report statistically significant cortical topography convergence, with Spearman-Rho of 0.72 and p less than 0.001, alongside cross-linguistic generalization across English, Chinese, and French. A human-validated taxonomy achieved Cohen's kappa of at least 0.74, suggesting substantial inter-rater agreement in labeling semantic features. For the interpretability community, this is notable because sparse autoencoders are typically framed as debugging tools. Here, they are operationalized as bridges between model internals and human cortical organization. If independently replicated, this approach could deepen collaboration between mechanistic interpretability researchers and cognitive neuroscientists, grounding model features in neurobiological evidence rather than purely internal metrics. Now, for a few other key updates in our lightning round. Researchers at Princeton University have developed Cumus, an embodied AI experimentalist that autonomously synthesizes graphene and fabricates atomically thin devices. According to an Arxiv preprint and coverage by the Quantum Insider, Cumus integrates large language models, robotics, computer vision, and automated lab hardware. It reportedly demonstrated AI-produced graphene, assembled 2D field effect transistors, and performed closed-loop parameter optimization. For materials scientists, this shortens the synthesis-to-device iteration loop in quantum materials research. Hadrian has open-sourced OpenHack under the MIT license, a file-backed workflow for AI-assisted vulnerability research. According to the company's Globe Newswire press release and HelpNet security coverage, OpenHack works within Claude Code, Codex, and Cursor, and includes 12 expert families aligned to OWASP Top 10 2025 and MITRE mappings. The workflow separates scenario scoping, expert validation, and independent triage to reduce hallucinated findings. In Rome, Politico and Business Insider report that representatives from Meta, Google, and Amazon met with Pope Leo XIV ahead of his AI encyclical titled Magnifica Humanitas. Religion News Service and NCR report that Anthropic co-founder Christopher Olah is slated to appear at the unveiling. The event underscores how AI labs are increasingly engaging religious and ethical institutions to shape normative debates. Finally, reporting from Financial News, Business Insider, and Hunt Scanlon indicates that McKinsey is shifting toward outcome-based pricing, with roughly a quarter of its global fees reportedly tied to performance-based arrangements. The firm's enterprise AI system Lily, rolled out in July 2023, is said to generate up to 30% time savings and more than 500,000 AI prompts per month. Deloitte is reportedly expanding its AI assurance practice in response. And that's your AI briefing for today. The landscape is moving faster than ever, and we'll be here to track it with you. For more insights, visit us at letsdatascience.com. Thanks for tuning in. Stay curious, and we'll be back tomorrow with the latest in AI.